Thank you, Patrika, and welcome everybody to the AI for 2021 Healthcare Summit. Again, a special thank you to our presenting sponsor, TigerGraph, who made much of this possible. As Patrika mentioned, I'm Daniel Lackland, content lead at AI4. Thank you for joining us today. Here with us, we have the entire healthcare ecosystem, from leading providers, payers, life sciences, medical device companies, PBMs, CROs, and of course, top healthcare AI startups. As an application-only event, you can rest assured that anyone you meet over the next 2 days will at the very least be an interesting conversation. As far as the content goes, I'm confident this event will be the high-quality peer-to-peer learning experience that the industry needs. Having worked with these speakers and panelists throughout the past 6 months, I'm absolutely thrilled to share their insights with you. The tremendous advancements that many of these leaders are spearheading across their organizations represent the future of healthcare. Even amidst a global pandemic, innovation in healthcare is proceeding at a thrilling pace, and I am so excited for AI's impact within healthcare to continue. Without any further ado, let me introduce you to our opening speakers who come from a very interesting company, Abhishek and David of TigerGraph. Abby runs the sales engineering team at TigerGraph and has worked with the majority of their customers in the healthcare, financial, and e-commerce domains. He has built his career around enterprise software, graph databases, and search engines. Prior to TigerGraph, Abby worked at McKinsey, Bloomberg, Cisco, and an NLP startup called Debismo as a founder. David is the director of product marketing at TigerGraph. David's primary responsibilities include understanding customer needs, bringing solutions to market, and driving product adoption. Prior to TigerGraph, David held senior marketing roles at innovative companies working on AI, natural linguistic programming, and telecom. Please join me in welcoming TigerGraph to the stage with some virtual claps.
Hello, and welcome to our presentation, Improving Quality of Care While Lowering Costs with Graph Analytics. I'm David Ronald, Director of Product Marketing at TigerGraph, and I'm joined by my esteemed colleague, Abhishek Mehta, Director of Field Engineering. Many of you in the audience may be less familiar with graph technologies, but Gartner Research, one of the most widely respected market research firms, is a huge proponent of graph technologies. In a report from February of 2021, this year, here's what they said. By 2025, graph technologies will be used in 80% of data and analytics innovations, up from 10% in 2021, facilitating rapid decision-making across the enterprise. So again, from 10% in 2021 up to 80% in 2025. So we're really at a point where there's going to be a sea change in the way data is analyzed as graph technologies moves on to the main stage. Gartner has also published quite a few reports on graph analytics, and one of these, called Understanding When Graph Technologies Are Best for Your Business Use Case by Jim Hare and others, describes 6 types of graph analytics shown here on the screen. So I'll start at the upper left and I'll go around this hexagon clockwise. Path. How do we find optimal paths or evaluate route availability? Community. Where are the clusters? What are the areas of focus? Centricity. What are the most important points in the network, either inside a community or outside of it? Similarity. How similar are nodes or groups of nodes in the network? Link prediction. This is all about determining the likelihood of nodes forming or breaking connections. And then last but not least, it's definitely not least, connectivity. How strong are the connections between nodes? You tie all this together, and it's not much of a leap to say that this can enable us to improve the quality of care while lowering costs, because we can find paths, we can uncover communities, we can identify centricity, we can measure similarity, we can predict links, and we can measure connectivity. And all of this provides healthcare organizations with richer insights into their data than you've ever had before. And I'm reminded here of a recent comment by a director of engineering who said, if graph is the new oil, then graph analytics is the refinery that converts that into the petroleum that is used to power your car. Powerful statement. Here's a real life example of graph analytics in action. This is a representation of a user interface available to medical staff in a call center. So this is our version, our anonymized version, fictional version of an actual interface that medical professionals in that call center are using every single day. So obviously, Doris Smith isn't a real person. The address, the phone number, they're not real either. But this is absolutely a close representation of what that interface is like. So Doris, as we'll call her, visited her primary care physician after surgery, as well as obtaining some medication from her pharmacy and embarking on physical therapy. Doris also made a couple of calls to the call center, and things were going well. However, in August and September, as we see here, there was a break. Doris appeared to stop all activity. The graph technology sitting underneath this user interface is able to match this behavior for a person of similar age across a data set of 50 million patient records and predict the likelihood of a negative outcome if Doris continues on this trajectory. That outcome could be the need for additional knee surgery or an associated problem, perhaps pain in our lower leg or something. And the graph was able to alert the call center staff, as we see here with these three exclamation points, and they took some action. They called Doris, and after speaking with her, they discovered that it was Doris's 20-year-old nephew who had been driving her to her appointments with a doctor for the physical therapy, to the pharmacy and so forth, and he had moved out of town for a part-time job. So the call center staff were then able to arrange for a driver to pick Doris up and take her to these appointments. The story is real, even if the data has been anonymized and the names changed and so forth. So in doing so, that healthcare organization was able to avoid the cost of additional medical procedures while improving the quality of care they're offering to Doris. And this is just one example of how graph can be used within a healthcare organization. And Abby will, in a few minutes, go into share other examples with you. And in addition to Gartner being a huge proponent of graph, UnitedHealth Group also is a huge proponent of graph. Ed Sverdlin at UnitedHealth Group has said, graph is the brains of the enterprise. In just 8 hours, we built a model that predicted disease using the connected data in the graph. He also said the value of graph is that not only can we monitor an enterprise, we can predict, and that allows us to avoid problems before they happen. Dan McCreary, who works at Optum, which is essentially the research and development subsidiary, the technology evaluation subsidiary of UnitedHealth Group, said, the number one business challenge we have been struggling with for the past 10 years and have really only conquered in the past couple of years with graph has been the process of creating an integrated view of our members. That's the view we saw on the prior slide. When somebody calls into our call center in the past, the call center staff would literally have had to log into 15 different systems to get that view, that integrated view. Now they can get that view from just that one user interface. And that user interface is generated in less than 50 milliseconds. So with that, I'm going to pass things over to my colleague, Abby, for a deeper discussion as to how graph can improve quality of care while lowering costs.
Great. Thank you very much, David. Let me share my screen. And all right, let me put myself in the presentation mode. Hello, everybody. Abhi here. And thank you, David, for the introduction. So now we will get into a little bit on the technical side of why graph databases are being chosen for these deep link analytical solutions. To begin with, your options are either RDBMS or NoSQL data stores, and both of them have challenges. If you look on the left-hand side, the RDBMS side, the challenge has been as the scale of data grows and you try to do this ad hoc query analysis, whether it's about machine learning feature extraction or just doing, some kind of machine learning algorithms, fetching the data out of the system itself is very expensive, time consuming, because RDBMS have joining problem, right? Because it's normalized data set, or it just cannot handle the ad hoc data querying at the scale. NoSQL on the other side is not that kind of interlinked and interjoined together, especially the kind of growth what we are seeing on the data side. Graph on the other side is totally different beast, right? If the storage of technology underneath is different, this is going to be more of a data-centric view where you are not joining the data set, but you're hopping into the memory location. Looking at this example, say this customer was your patient and all the patient visits are going to be just one hop away from this patient ID. And what happened, what treatment was given, what drugs were provided to them will be one hop away from that treatment plan. So rather than going into various different big tables and trying to find and look for the information what you want to join together inside your application or whatever business case you're solving, in Graph, you're just hopping onto the memory locations. As you look at these advantages on the Graph side, the logical question in everybody's mind is that, listen, we do not have this kind of data set, or my data is not ready. My data is not ready just to do graph analytics because I don't store data in graph format. That is not required. Your data can be pulled into Graph, whether it's from RDBMS, NoSQL store, your IoT data, your devices, your legacy data. You can port the data directly into Graph databases with very minor modification. You don't need to run a full-fledged project to get your data inside Graph database. Now, what did that solve? If it is so easy to bring in the data into the Graph, look at the picture on the right-hand side. You may have patient record, you may have physician's records, you may have clinical research data, you may have sales and marketing related data, but the challenges on all those sides is that this data is siloed. So we de-silo your data. When you bring data in Graph, it gets de-siloed. Your data formats are taken care of. Data privacy issues, about which I will talk later on, is also taken care of, whether it's about PII or HIPAA compliance. And advantage which Graph provides you is that once you have data in Graph structures, you are enabled with many more machine learning algorithms, which are not usually available to you when you have two-dimensional data. And explainability is built inside the Graph itself. And of course, the scale, that's where the Graph and the TigerGraph actually comes in and gives you the biggest advantage. We'll talk about it as we proceed through this example. So Doris's example, which David was explaining you early, this is an example of a system which is highly analytical, joining data set from different sources and acting and reacting, as David was telling you, that this is somebody from a call center agent suddenly getting the details about Doris, whether he's about to call her or whether she is calling him. Imagine the kind of data which has to be joined together: enrollment record, pharmacy claims, prescription records, maybe chat transcripts. They all have to be joined together and structured in the flow what is shown you on the screen. Another way of looking into it is that if you're in a biosciences field and you are having electronic medical records and you want to see what are the side impacts of the drugs which have been given to a person, or maybe you are joining with the human gene records from the diseases side and see how the nomenclature of genes are reacting with the proteins and what are the similar proteins, and all of this data comes from different kind of data sources, and now you are trying to find comorbidities based on genes, or you are trying to do some potential drug discovery based on similar proteins. Easier said than done. This data has to be connected and scale and has to perform in matter of milliseconds or seconds on terabyte scales of data. How do you do that? That is what Graph enables for you. Once you have this data structured inside Graph, as I was saying early, you are enabled with various different algorithms, which was not possible early. Look at this deep link analytics solution. You can hop from one point to another in matter of milliseconds. You can do query pattern detection. You can do page ranking algorithms to find out who's the most influential prescriber in a region, or maybe you can look into the pharmacy or referral frauds, or similarly hub and community detection to find similarity of the patients. So once you start putting your data into graph structures, you enable yourself to run very, very powerful machine learning algorithms, which till now was expected to be only running at LinkedIn's and Twitter's and Facebook's because they are technically graphs. Now we give you the power in your own hands to do this on your own data sets. Here is another example of inferring a referral relationship among the prescribers, right? A doctor, Helen Sue, is filing a claim on a patient on whom many other doctors have also filed claims. Can we infer that maybe Helen Sue has referred this patient to Douglas Thomas? And if you can infer that based on whether there is a claims form which contains the referral code, or whether you can just conclude that the journal prescript, you went to a journal practitioner and from there you went to a cardiologist, and that there is a possible referral out there. So you can do many such assumptions. And once you connect these kind of dots together in your data set, what you have is a network of graph ready, which can do much more smarter algorithms of, for example, page ranking, finding the most effective prescriber in a community. And now your sales and marketing department, when you launch a new drug, can find out who are my most influential prescriber in New York City. So all that can be done once you have data done in graph analytics. Another aspect to look at it is into the hottest topic out there, right? On the natural language processing. Let's say you are doing some clinical name entity recognition. Here's an example. Somebody suffering from diabetes has been given amoxicillin, and their physical examination results are out. What you can see in green is the drugs being discovered. So this can be used and done in an external natural language processing system. But the question is, once you have recognized this information, what is that you want to do on top of this, right? It's just not you're making effective search engines. You want to do higher level business analytics on top of it. Like, let's take an example of saying that finding a query, what is the side effects, or how many people are there in the world or in the United States are undergoing amoxicillin treatments for diabetes, and what is the impact of that on their physical examinations? What are the pellet counts? Or what are the RBCs? So these kind of analytical operations require you to do the basic operations like entity recognition over here, combine it with external data set to answer higher level questions. And when you look at this into perspective, you will see that many different data sets have to be joined together, and the system has to perform and scale, and RDBMS does not scale out to that. And if it is a real-time use case, even the most regular, for example, Spark-based, parallel computing will not help you if the data set is changing rapidly in the real time. Here's an example of how would you do an NLU system based on TigerGraph, right? On the left-hand side, you're doing all these entity extraction. Connected data set is basically coming into TigerGraph, and from there, you're doing the learning based on this connected data. So all these sets joined together will give you a graph-based natural language understanding system. Another aspect of looking into the system is that when you are joining this data set together, let's say on the left-hand side, you have Medicare record. On the right-hand side, you have adverse effect of the drugs, and both are joined together with the drug names. Now, the question here is that, can you really do that? If this is a real-world data, if it is not this kind of open source data, then can two data sets in your world be merged together at ID level or a drug level? And answer to that is no, that is not possible. And the reason is that there are privacy, regulation, risk, laws, enterprise architecture, committees, compliance challenges. You just cannot join that data set together. It's easier said than done. You say, Abhi, you're saying join the sets together, but we have rules to follow. So for that, Graph has a solution, especially the TigerGraph has a unique feature in which the primary citizens of your data, of your graph, are nodes and vertices. So you bring in these nodes and vertices inside TigerGraph, and then you decide what kind of graph you actually need. And you can pick and choose what attributes, what nodes, what vertices go into one kind of graph, which is publicly available to your product department to research on, and another graph which goes to the clinical research department, and there is another one which goes to the IT department, so that your PII information is not shared between them unless you want to. So you can create these shareable graphs on your enterprise level and serve your various different lines of businesses. One of the biggest advantage, I would say, why we are at TigerGraph and why TigerGraph serves it better than some other competing technologies out there, because we are world's first native parallel graph with a distributed graph, with a distributed graph with a native parallel NPP architecture. What does this mean? Is that our system is not just storing your data distributedly, it's also processing it distributedly. We can scale up and out. That means that you can have gigabytes of system, you can have terabytes of system, or you can have even petabytes of information stored inside the graph and on much more cheaper hardware. So you can scale it parallelly rather than scaling the system up horizontally, which keeps your costs very high. Similarly, deep link analytics underneath our system, there is a C++ engine, which makes it possible for you to go 5, 10, 20 different hops if you have need to do that, and also in very shorter amount of time than other technologies which are based on high memory consumptions of Javas and like. Our programming language, there is no standard graph programming language. We are all working towards standardization. So our language is built ground up for distributed computing and processing, and that's called GSQL. And also we have inbuilt graph-based algorithm libraries, which are all written in GSQL, which come out of the box with our system. And again, multi-graph, I've already explained to you. We have a visual SDK for you to develop a system, right? It's a Visual Studio. It's a visual SDK where you can look at, we don't have a chance to show you the demos today because of the time constraint, but you can look at our website and you'll see how easy it is to create graphs out of that. And of course, we have keeping your cost of ownership low. We compress your data down up to 40-50% of its original value, and asset compliant. It's a database which is capable of doing both online transaction processing and online analytical processing in a single system. So with that in mind, I would say I'll give you opportunity to look at our website. It is tgcloud.io. And we have many different use cases. We have starter kits out there for the healthcare sector, for which you can get started very easily. But other than that, if you have any question, our emails are flashed on your screen. Feel free to reach out to us. And I would say thank you for joining our session. Back to you.
Thanks, Abhi and David. That was an amazing way to start off AI 4.